A table doesn't necessarily need to have so many rows or cells to make a question complex. Small tables can still provide some challenges. Again, knowing when and how to use the sorting function will mitigate against detailed searches for data. Let's take a look at an example here. This table has fewer rows, but don't assume that means you're in for an easier time. The questions are likely to compensate for the graph's simplicity. They may require abstract reasoning, synthesis of multiple data points, or both. Begin as always by reading the paragraph of text that accompanies the table. It tells you that the table provides data about the number of households and the size of those households in several New England states. Now look at the table itself. Note the column headings, which are broken down into households of 7 different sizes, plus the total number of households for each of the 5 states. Table analyses will always be accompanied by a single series of questions. You're asked to assess if each statement is true or false, although other formats such as yes, no are possible. Let's start with the first statement. The first one asks you to find the percent difference between 2-person and 3-person households in New Hampshire, and compare that to the percent difference between 2-person and 3-person households in each other state. Recall that percent difference can be calculated by finding the difference between the two numbers and then dividing that difference by the original. Now look at the table. For New Hampshire, that's 189,000 minus 85,000, all divided by 189,000. Plugging this into your calculator gets about 0.55 or 55%. This is a good opportunity to use the on-screen calculator to avoid difficult math. Note also that you should round those numbers to the nearest thousand before entering them to reduce the odds of misentering data. In order for New Hampshire to be the largest, all other states must have a smaller percent difference. You've got 4 more states, so think strategically. New Hampshire has more than a 50% difference, so if you can determine that a given state has less than a 50% difference, there's no need to do the actual calculation for that state. In this way, you know that you can eliminate Connecticut and Massachusetts, since you can look at them and see that there's slightly less than a 50% difference. The 3-person household number is slightly more than half of the 2-person household number in each state. To prove this statement false, you only need to find one state that has a difference larger than 55%. If you see the numbers for Maine, you have about 214,000 minus 84,000 divided by roughly 214,000, which is approximately 0.61 or 61%. Since Maine has a higher percent difference, this statement must be false. Note that the difference of 6% is a relatively significant difference. The GMAT is very unlikely to ask you a question for which the exact values matter down to the decimal place, so rounding was a huge time saver. Here's the next one. Now you're being asked to determine the median household size for all states combined. You'll first need the total number of households for all 5 states, which is in the far right column. Round each total in the total households column to the nearest thousand, then multiply by 1,000. You get 1,000 times the quantity 1,371 plus 557 plus 2,547 plus 519 plus 256 and quantity, which equals 5,250,000. That means that if you were to place all these households in order according to their size, the median household would be roughly the 2,625,000th household. The household size of the 2,625,000th household is therefore the median household size. To determine the size of that particular household, you need to know the total number of households of each size until you hit the 2.6 million mark. Starting at either end of the table will eventually get you to the middle, but because there are bigger numbers of smaller households, you'll reach the threshold faster if you start on the left with the 1-person households. Rounding to the thousands place gets you 1,000 times the quantity 374 plus 160 plus 732 plus 133 plus 72 and quantity, which equals 1,471,000, So you're a little over halfway to the 2,625,000th house. Careful observation saves even more work on the next step of finding the solution. Every state has more two-person households than one-person households. So the total number of one- and two-person households must be at least double the 1.4 million mark, or 2.8 million. Therefore, the 2,625,000th household must be a two-person household. So this statement can be marked true. And now the last one in the set. From your first glance at the table, you notice that Massachusetts has by far the largest total number of households. So you can guess that Massachusetts might be the greatest in every subcategory. You can sort the tables as before to determine the rankings of the states in each column. For each one, you need to determine whether the number of households in Massachusetts is greater than the second highest state plus third highest state. Perform the calculation for each household size category, and where possible, use approximation instead of calculation. For the one-person households, is 732,263 greater than the sum of 373,648 and 159,533? Again, use estimation here. 374,000 plus 160,000 equals 534,000. So Massachusetts definitely has more for this category. Do the same thing for all the other categories. For the two-person households, is 813,000 greater than the sum of 443,000 and 214,000? Absolutely. For the three-person households, is 417,000 greater than the sum of 227,000 and 85,000? Yes. And for the four-person households, is 354,000 greater than the sum of 197,000 and 71,000? Yes. For the five-person households, is 151,000 greater than the sum of 85,000 and 27,000? Yes. For the six-person households, is 51,000 greater than the sum of 29,000 and 9,000? Absolutely. And for the seven or more person households, is 29,000 greater than the sum of 16,000 and 4,000? Yes. Since Massachusetts is higher than the next highest two states combined in each category, the answer here is true. Note that you didn't need to perform the exact calculations for any of these comparisons. Once you identified the correct values to compare, you could estimate the sum of the second highest state plus the third highest state and see that in each case, it's less than the number of households in Massachusetts. As in the case with all integrated reasoning questions, get the gist of all the data. This is the question type that probably gives you the most pure information, and most of the data is actually unnecessary. Don't let the numbers distract you from the task at hand. Second, know when to sort, and even when not to sort. Keep an eye on the task at hand. Remember that you'll always have the luxury of sorting tables in this question type, but be efficient on how you use it. That can mean the difference between a good score and a great score for integrated reasoning.